We hear now Armchair Astronomy with members of the American Museum Hayden Planetarium staff talking to WBAI's David W. Teskey.
This is the 48th in our continuing series of programs on astronomy. Contributing their time and knowledge to this venture are members of the American Museum Hayden Planetarium staff. They come hoping to give us laymen a fuller understanding of our universe. On today's program, the topic of the discussion is Comet Ikeya-Seki. With us today is astronomer Dr. Kenneth L. Franklin and astronomer Dr. Thomas G. Nicholson of the American Museum Hayden Planetarium. Welcome, both of you, and Dr. Nicholson, will you begin?
Thank you, Dave. Today we'd like to talk a little bit about something that was very, very much in the news just about 2 months ago now. It was a very hot news item. Today, I guess the world has all but forgotten about it, all except the astronomical world, which is still following the object with interest. And that, of course, is Comet IkeyaSeki. Right now, Comet IkeyaSeki is still moving in its orbit, now moving out away from the sun. It has faded quite a bit now. It's down well below naked eye visibility, down to an estimated magnitude of very close to +8. This is, we know, is a diffuse magnitude of the comet head. It's not a point source, and therefore it would be more difficult to observe telescopically than would a star at magnitude +8.
That's about the same brightness it was when it was discovered September 18th by Ikeya.
And telescopically, a comet of a magnitude +8 is not too difficult to see.
It's a fairly bright comet.
You don't need a big telescope to see it.
No, probably any ordinary amateur.
Any
good
6-inch telescope would be able to find it easily.
Right.
Where is it? Well, about now, Comet IkeyaSeki would be in the best position to be observed along about 3 o'clock in the morning. Of course, it takes a real avid amateur astronomer to be up there looking for something at 3 a.m. I say this because the comet is now quite far in our southern sky. It is declination about -36 degrees, or 36 degrees south of the equator, which means as it crosses our sky on a rather low arc over the southern horizon in the early morning hours, it never gets more than about 14 degrees above the horizon. About 3 a.m., Comet IkeyaSeki will be just about 14 degrees above the southern horizon for anyone who wants to look at it with a respectable amateur telescope.
In the New York vicinity.
In the New York vicinity, of course. Its distance from the Earth hasn't changed very much. The kind of orbit it is in is such that it never changed its distance from the Earth by a very great amount, although its distance from the Sun changed radically. It is just a little bit more than 1 astronomical unit away from us, roughly 95 million miles or so. That is, the astronomical unit is 93 million miles. The comet is a little more than that. It is about 1.4 astronomical units away from the Sun. It will probably remain a telescopic object for at least several more months.
And I assure you that professionals that are interested in this will be following it until it gets down to 19th magnitude.
I mentioned a moment ago that the world has all but forgotten Comet IkeyaSeki by now. However, 2 months ago, Comet IkeyaSeki was very, very much in the news, and we certainly can attest to how much interest and excitement this very unusual object generated, at least in the New York area.
We were aware of the fact that this was going to be quite an interesting comet long before the people in general in the New York area were aware of it. We get information from the International Astronomical Union, as most professional organizations in astronomy do, and the telegram came to us about the 19th of September, or the 20th, stating that there was a comet discovered by Ikeya and Seki in Japan.
I might say that this was not an unusual telegram nor an unusual discovery as far as we knew at the time.
No.
It was just an announcement that a comet was seen by these 2 amateur astronomers, and apparently it was a new comet, but that is not uncommon.
No, but the one thing that was a little bit unusual about it at that time was that it was 8th magnitude, and this is rather a rare thing, to find a comet for the first time that is rather bright.
Providing we add one other circumstance, it is rare to find a new comet at 8th magnitude if we know that this comet still has some distance to go before it gets close to the Sun.
Well, no, I don't think so. It still is a rarity to find an 8th magnitude comet that was not seen when it was 10th magnitude, say.
Well, that's true.
But the fact that it had some distance to go and still was 8th magnitude, sort of portended something quite interesting for
But
it.
we still didn't know at the time of the discovery that it had a great deal to go before it got to the sun.
Not at all. And then the observations began to come in from the International Astronomical Union, which has the headquarters for this particular activity in Cambridge, Massachusetts. Now, the first problem when you discover a comet is to find out what path it is taking. And in order to find out what path it's taking, you have to have observations of it in the sky. Now, the problem is a little bit difficult because we're watching an object in motion from a platform that's moving, namely the Earth. So it's a little bit of a problem to do this. Now, the very first observations that came in apparently were not very good. And the observations that were used by some of the comet orbit computers yielded some very funny orbits for it, especially when we look at it in retrospect.
Orbits which were not very exciting, but which seemed quite strange.
Well, here was one that was computed in Prague that gave a distance, the closest distance from the sun that this body would get to be was about 9/10 of an astronomical unit, say 80 million miles. And furthermore, it had it going around the sun in the same direction that the planets go around the sun. And on this same card from the International Astronomical Union, there is another orbit showing that this same body was going to get about 30 million miles from the sun, and that it was going around opposite to the direction from that the planets go.
It seemed at first glance that these two orbits were talking about two different objects.
Absolutely two different objects. Well, this just shows a little bit of the confusion that was here early in the observation of this body. Now, I might point out that was 10 days after the discovery of this comet. And now that's unusual.
I would say also that up to this point we still had no real inclination that this was going to be a special object.
No, not at this time.
The surprise came, however, on the next circular from the International Astronomical Union. Dated October 1st, it gave what was probably a very accurate ephemeris based on accurate, precise observations of the planet. The orbit described on this card indicated that the planet was going in a retrograde, the comet was going in a retrograde path around the sun, coming from far to the south of the solar system, but on an orbit which would take it at its closest point to the sun, perihelion, to a distance of 0.0045 astronomical units.
I might point out that the radius of the sun, Tom, is 0.0046 astronomical units.
In other words, if this orbit were correct, the new comet was going to pass around the center of the sun closer than the sun's surface.
Right, it was going to dive into the sun. Now, it was on the basis of this orbit that Dr. Whipple at the Smithsonian Astrophysical Observatory pointed out the fact that this was a member of the sun-grazing group of comets. Now, the other numbers that describe the path of this body in space agreed very well with the numbers that describe the paths of about 7 other comets.
Now that we knew something about the orbit of this comet, several things became quite apparent. When it was discovered on September the 18th at magnitude +8, it was about 95 or so million miles away from the sun, we know now. Now, realizing that it eventually was going to come within a few 100,000 miles of the sun's center, and knowing its orbit, an ephemeris, a table of its future positions and future behavior, could be calculated for it. Now, this ephemeris would have to reflect the fact that from the time of discovery until it approached the sun, its distance was going to change by an enormous amount. The first date on this ephemeris was October 1st, and on that date, the distance of the comet from the sun was 75 million miles, and its magnitude was estimated to be about +6 on that date, October 1st. Now, if it was going to go from 75 million miles away from the sun to within a few 100,000 miles of the sun, then its brightness was going to have to change quite a bit. So immediately, we could predict for this comet a great increase in brightness, since its distance from the sun was going to change so radically. Apart from this, there was the very close resemblance of the path of this comet to the path of the very strange members of the so-called sun-grazing comets. And immediately astronomers began to look into the history of these sun-grazing comets and see what had happened to them.
I might point out here at the moment that the orbit that predicted that it would go into the sun was still not a very accurate orbit, and that an orbit by Dr. Leland Cunningham at the University of California predicted that it would pass above the surface of the sun by about 300,000 miles. And it turned out that his orbit was by far the most accurate of any of those that came out. And that's just about what that comet did. It passed about 300,000 miles from the surface of the sun.
So it was by October 1st, certainly by October 4th, when Dr. Cunningham's orbit came through, that we realized this was certainly an exceptional object. We knew that for two reasons. First, it would have to get that so much closer to the sun that all the laws of nature would indicate it must get very bright. Secondly, by going into the history of the sun-grazing comets and realizing this one was one of them, we could see how they behaved. And if this one behaved at all like some of the others, it was bound to become a very interesting object.
The first one of these that we have, or any record of, was the comet of 1668. It passed just exactly like this one did. The next one was
43, number one.
1843, the first one to pass the sun that year. The next one was 1882.
There was a comet of 1880, which was also a member of the
1880,
group.
that's right.
Then 1882 came along, and then 1887. There were four known members of the group in the 19th century.
Right.
Of these four known members in the 19th century, two of them were particularly outstanding. There was the comet of 1843-1 and 1882-2. 1843-1 developed what most comet authorities recognize to be the longest tail in the history of cometary observation.
It's about 2 astronomical units.
Yes, twice the distance from the Earth to the Sun, about 180 million miles long. The comet 1843-1 was bright enough at times to be visible in the daytime without any telescopic assistance. Now that's very unusual for a comet to be visible in the daytime sky. Because when the comet gets bright enough to be seen in the daytime sky, it is extremely close to the sun, and it would have to be much brighter than, say, Venus, when Venus is visible in the daytime sky, because Venus is quite far from the sun. Comet 1843 met these characteristics. Then Comet 1882 also met these general characteristics. Its tail, although it never got as long as Comet 1843, did get to about 40 degrees in length, and Comet 1882 was reported to be seen in daylight without telescopic assistance by several observers. I might point out one thing also. These strange sun-grazing comets had many characteristics in common with one another. One was the extremely long tails they developed. Another was the great brightness that they achieved. Another was the fact that they all came so close to the sun. Another was the fact that some of them had broken up, had suffered very great disturbances in passing so close to the sun. But another unfortunate characteristic of these sun-grazing comets is that their orbits are such that we in the northern hemisphere are never really in a good position to see them favorably. Their orbits are such that, first of all, they could be missed entirely. There might have been a great many other members of this group that just were never observed from the Earth.
At the wrong season, we would just lose them completely.
No one on Earth could see
Right.
them. Comet 1963 is a case in point. That almost was missed.
It was discovered on the way out, and this is one of those too, one of those sun-grazing comets.
That's right.
But it was only 6th magnitude, discovered on the way out. So not all of these things have been spectacular. And unfortunately, comets in general are notoriously unpredictable in their brightness characteristics and in their generation of tails and so on. So we had a bit of a problem trying to figure out what was going to happen to Comet Ikeya-Seki.
But we knew this. We knew that Comet IkeyaSeki, as one of the sun-grazing groups, was never going to be in a good position to be seen from the northern hemisphere. But as far as this sun-grazing group was concerned, Comet IkeyaSeki, like the comet of 1882, was in just about the best possible position for observation from the northern hemisphere.
Yes, it really was the best that we could hope for
this kind of comet.
for a bad situation.
Right.
Well, this was very curious, Tom, because as soon as the newspaper strike was over here in early October, people began to get very excited about it in the New York area. I might point out that up in Boston, the people at the Smithsonian Astrophysical Observatory said that there was a great deal of excitement up there.
And I know also there was a great deal of excitement in California centered around the Griffith Observatory, because I've been in touch with Dr. Clemenceau out there and know what happened there. The storm here, the storm of public interest, broke, I would say, on the weekend of October 9th and 10th.
Yes, I think so.
And for the following 2 weeks, the storm continued practically unabated.
Well, in fact, it increased tremendously.
Yes.
I think that it might be interesting just to recount some of the experiences we had around here with people calling us up.
Yes. We know just about how intense the storm of public interest was, because we maintain at the Hayden Planetarium here in New York a telephone answering service to provide the public with information about artificial satellites and other interesting celestial objects that may be in the sky. This telephone answering service answers to the number Trafalgar 3 0404 and provides the caller with the information about what may be in the sky at the time. Up until October 9th, the daily use of this service had averaged a little less than 100 calls per day. On the weekend of October 9th and 10th, the service was answering an average of about 700 calls per day over that weekend. And for the next 2 weeks, the average jumped to over 1,000 calls per day, reaching a peak on October 21st of over 2,400 calls per day. Now, October 21st was an especially important day.
Those numbers count from about 10 o'clock in the morning to 10 o'clock in the morning. And the over 2,400 calls primarily occurred from 10 o'clock on the 20th to about 10 o'clock on the 21st. It was at this time that Comet IkeyaSeki was going to get so close to the Sun that if it ever was going to be visible in the daytime, that would be the time. On the afternoon of the 20th, it should have gotten quite bright, and it did get quite bright. Out in Arizona, Dr. Elizabeth Romer said she could step out of her office and look at it anytime she wanted to. But that was not true here in the New York area.
And that was part of the problem. For this almost 2-week period from October 9th until October 21st, apparently many thousands, if not millions, of New Yorkers wanted to see this comet. Unfortunately, the comet was not in a good position to be seen. Throughout all this time, the comet was rising in the morning sky before the sun. So first of all, you had to get up early to see it. Secondly, although the comet was getting brighter as it approached the sun, it was also appearing in brighter and brighter portions of twilight, since it was rising later and closer to the time of sunrise.
The competition was too much for it.
Up until October 16th or 17th, it could have been seen in the twilight sky before dawn.
We did have a few reports of
very few.
sightings.
The problem was one of its unfavorable position, but also one of, unfortunately, a spate of very poor weather here in the New York and, as a matter of fact, the entire eastern area. From early October right up to the 21st and 22nd, our morning skies were either cloudy, hazy, or absolutely foggy. So that even those New Yorkers who were curious enough to get up at the time they wanted to get up and to look in the place where they should be looking just didn't find clear, low, east-southeasterly horizons in which to find the comet.
Well, then the trouble came also on the 20th in the afternoon. That was, for us here, a rather miserable day as far as weather was concerned. High humidity, haze, in effect, a rather smoggy atmosphere.
The sky looked quite nice and blue until you looked at it with a pair of binoculars and you could see the clouds all over the place.
Clouds, well, then there was a high cirrus cover as well. And on occasion, we could also look out there and see a few vapor trails. And we did get reports from people who said they had seen the comet in its tremendous tail, and I'm afraid that they were reporting the vapor trails that we could see there.
But all the time on that afternoon, the comet was, as astronomers had predicted, bright enough to be seen in the daytime sky.
And it was in a good clear sky. Well, now then, this was happening on the afternoon of the 20th when the comet was approaching very, very close. Just about midnight for us here in New York, the comet was going to be at its closest, 300,000 miles from the surface. For about 6 hours, it was going to be within 1,000,000 miles of the surface of the sun. And something surely might well happen to that body at that time. This is a tremendous heat shock that this cometary body was going to get. Effectively, the comet is a mass of frozen gases, much like dry ice. And when it gets a good solid shock of heat like this, it's a little bit like pouring boiling water into a cold glass. Something's liable to happen. Well, we didn't know what. We had no idea. What would happen to this comet when it came so close? We would not know here in the New York area until the morning of Thursday, October 21st. Tom, what happened to you on that morning?
Well, we knew definitely on the 20th that the morning of the 21st, based on the weather forecasts, were not going to be good. There would be no possibility of observing the comet that morning from the ground. However, fortunately, we had offers from two agencies to provide us with air transportation to get above local ground problems. Transworld Airlines, through the courtesy of Walter Menck, the Director of Public Relations, was good enough to make available a 727 jet aircraft on which we could fly to see if we could see the comet in the clear skies above the ground weather. That morning, we managed to take off, in spite of the foggy weather that persisted in the New York area, about 5 a.m., flew to an altitude of 38,000 feet, to a point which was several hundred miles to the east of Montauk Point off Long Island, and we looked for the comet in the morning sky before sunrise and after sunrise, and unfortunately we could not see it. I can well describe what we did see. The sky was exceptionally clear. The eastern horizon was exceptionally clear, except that very close to the horizon there was a distinct layer of clouds obscuring the natural horizon of the Earth. Above this layer of clouds there were several thin layers of haze. We could see the sun come up clearly above the clouds, but as it passed through the haze, it brightened very rapidly. By the time the entire sun was above the cloud level, the eastern horizon was so brilliant that, search as we might with binoculars from this aircraft, we simply could not see the planet in the vicinity of the sun. But what happened to you, Ken?
Well, I was in another airplane. Roger Tuttle of WNBC had contacted the Cessna aircraft people out here at Morristown, New Jersey, and Bill Marriott provided us with an airplane, and Harry West flew this up to about 10 or 12,000 feet, somewhat north of West Point, I think. We got up in a very foggy ground situation, and about 6,000 feet we broke out of the clouds, and it was beautifully clear above that. And Roger Tuttle had an FM transmitter aboard, and when we got up, we contacted WNBC and gave a live broadcast of our experience. As the sun came up, it rose up into a layer of haze for us. And this haze completely, well, not completely, but seriously cut down the light from the sun itself. And as it was deeply involved in this haze layer, above the haze layer, in just about the position I expected to find it, I did spot the comet. There it was, a tiny little point of light. I gave the glasses to Roger Tuttle, and he saw it too, but it was not an impressive sight to just a casual observer unless you knew what the situation was. And of course we did, and to us it was very exciting to see the fact that the comet did survive its pass around the sun at that time, and there it was. And for most New Yorkers, this was probably a revelation that the comet really did exist, because so many had not seen it at all. They were beginning to doubt that it was true, that it might have been a hoax or a publicity stunt of some kind or other. But no, it was really there. We did see it.
You have to bear in mind that astronomers had been saying since about October 1st onward that this comet was probably going to become one of the most spectacular comets of the 20th century. And now, after millions of persons throughout our country had spent many hours searching for the comet and hadn't seen it, they began to wonder if astronomers were crazy. What was a spectacular comet in astronomers' opinions?
Well, this was.
Well, we have to ask ourselves, just what is a spectacular comet? Well, certainly any comet which becomes bright enough to be seen in the daytime is an extremely rare and spectacular event. This comet was. Certainly, I would say any comet that develops a tail in the order of 40 to 45 million miles long must be considered a spectacular comet. And I can say this comet did, because I saw a tail later which was at least that length. Now, this brings up the very interesting part about this comet story. Up until October 21st, public interest was at the storm level. To my way of thinking, to my experience, I would say public interest in this comet was greater than interest in any celestial event that occurred since the launching of the first Russian Sputnik. We experienced a great many surges of public interest in astronomical events here at the planetarium. The level of interest in this one exceeded any event since the launching of the first Sputnik. But throughout all this interest, nobody, or very, very few persons, were able to see the comet. Then suddenly on October 22nd or October 23rd, the interest just dropped. The level of telephone calls we receive on our answering service, dial satellite service, dropped back to normal levels by October 23rd or October 24th. And then it happened. Then suddenly New York experienced a quite different weather pattern. Beginning on the morning of October 27th, I would guess, and continuing for about a week or 10 days, we had a spate of very clear, cold mornings. Mornings on which the horizon could be seen right down almost to the very level of the ground itself. Mornings in which you could see stars with the unaided eye down to within a few degrees of the horizon. Mornings on which with binoculars you could see a star like Arcturus at the instant it rose, a first magnitude star. Well, these were the mornings when we here in New York might begin to see the comet, because the comet was then returning to the morning sky, moving again to the west from the sun. It was getting farther and farther from the sun each day. True, it was getting fainter each day, but in addition to getting fainter each day, it was rising in darker and darker portions of sunlight, of twilight. Now, it was at this time that the comet, as so often happens with comets, developed its really good tail. It often happens that comets develop their most spectacular tails after they round the sun, and that happened with the comet Ikeya-Seki. What it was like? Well, it's very easy to say because I saw it, as did most of our staff, several mornings over that week or so from October 27th on. I saw it on the morning of Saturday, October 29th. I believe that was the date, and I saw it 2 mornings after that. Looking into the horizon a little to the south of east, about 2 hours before sunrise, I saw the tail, extending almost vertically above the horizon, not quite. It was rather faint, but after all, it was competing with the horizon haze, seen to the south of east right over New York City, where New York City was lighting up the low sky. You could see it clearly with the unaided eye. You couldn't miss it. The tail was right there. With a pair of binoculars, you could trace the tail along its entire length. A little later, as the tail rose higher, the comet head came above the horizon. Without binoculars, I couldn't see any detail in the head, although I could see where it was. With binoculars, while the head of the comet was within 5 degrees of the horizon, or less than 5 degrees, I could clearly see the small, tiny star-like nucleus of the comet, appearing by then, October 29th, as a star of about 3rd magnitude. And the tail of the comet stretched from its head for a distance of at least 20 degrees across the sky. Translating that into linear distance, the comet at that time was nearly 90 million miles away from the Earth. 20 degrees at a distance of 90 million miles is in the order of, I would guess, 25 to 30 million miles in length. So I was looking on that morning at a tail which must have been at least 25 to 30 million miles in length. Other reports from observers who watched the tail from other parts of the world under better conditions reported that the tail of the comet had at times exceeded 45 million miles in length. The tail was curved slightly, quite slender and narrow, curved markedly towards the back end of the tail. Quite homogeneous, there were no knots or irregularities of brightness visible in the tail. And on the several mornings after the 29th when I saw the comet, it fit this description also. So Comet IkeyaSeki was there, but after the 21st or 22nd or 23rd, people suddenly seemed to have lost interest in it. And when they could have seen it, they just didn't bother to look.
That's a very curious commentary on people's interest in astronomy.
Thank you both very much. We have been listening to astronomer Dr. Kenneth L. Franklin and astronomer Dr. Thomas D. Nicholson of the American Museum Hayden Planetarium speaking about the recent Comet IkeyaSeki. We hope you will join us next week when both of the gentlemen will return with Dr. Franklin M. Branley to discuss Life Beyond the Earth, the first of 2 programs speaking about extraterrestrial life. We hope you will join us, and if you have any questions or topics you'd like discussed on future programs, indicate them by card or letter to Armchair Astronomy, WBAI, 30 East 39th Street, New York, 16, New York. We will try to answer as many questions as possible in future programs. Until next week, Good day.
This has been Armchair Astronomy with members of the American Museum Hayden Planetarium staff talking to WBAI's David W. Teskey.